Okay, so let's talk about one of my personal favorite things, U substitution. So we can do the same thing whenever we see chain rule and use this thing called U substitution, where we change what our function looks like in order to make it easier. So the first thing we're going to do is decide on what U is going to be. Generally, it's going to be our inside function when we think about that composition of functions for our chain rule. When we take the derivative, we're going to take the derivative of u equals to whatever it is. This is going to give us du is equal to something dx. This is kind of a weird caveat here. A lot of times we would normally do du over dx, but we're not really multiplying by dx because that's a label. So there's this kind of like weird, we need du and dx to do integration. That's the main reason it's there. Decide what we have in the problem versus what we need. Substitute u and du in for our problem. When we're done doing this, there will be no x's. Integrate. It should be a lot easier this time, and then substitute our x back in for whatever u is. So if we look at this problem again, so cosine of 3x plus 5, we are going to make u that 3x plus 5. It's that inside of cosine. So 3x plus 5. If I take the derivative of both sides, we have du is equal to the derivative of 3x, which is 3, and it was with respect to x dx. So this is what we have. So what I want to look at here is what we have versus what we need. So if I were to write what we have right now, we have the integral of cosine of 3x plus 5 is now u. And we have dx. Well, we don't have dx by itself here. We have du is equal to 3 times dx. So we're going to go ahead and try to move this around so that way it is by itself. So we're going to divide both sides by 3. I do not like the way du over 3 looks, so I'm going to change it to 1/3 du. So we have 1/3 du equals dx. We are going to be substituting that indirectly. So instead of writing dx, we are going to write 1/3 du. We have no more x's in our problem, so now we're going to integrate. One thing that I'm going to do to make it easier on me is I'm going to take that 1/3. It is a constant, so I'm going to move it out front. So I have 1/3 the integral of cosine u du. So we're doing the integral of cosine of u with respect to u. Our 1/3 stays put. The integral of cosine is sine, and it's just sine of u because we're taking it with respect to u. And then we add our plus c. Now that we have our integral, we're going to go ahead and plug back in so it is in terms of x. So we have 1/3 sine. U is equal to 3x plus 5, so we have sine of 3x plus 5 plus c. This way may or may not be faster or slower than the other one, but this is like our base example for U substitution. So we're going to look at some other problems here that are a little bit different, starting with this one. So one of the things that we notice here is that we have the integral of the square root of something that is not just x. So U substitution can automatically be used here because there is an inside and an outside function. So if we look here, I'm going to make my inside function 2x minus 1 because it is inside of the square root. So 2x minus 1 is equal to u. I'm going to take the derivative of both sides. So du is equal to u. The derivative of 2x is 2, and it was with respect to x. So now we're going to go ahead and put some stuff back into our problem. If I look at what we have here, we have the integral of the square root of 2x minus 1 is now u. So the only thing that we haven't taken care of is this dx. So when I'm looking at this here, this is taken up by this. So I need dx to be by itself. Right now it is not. So we are going to divide both sides by the 2. 1/2 du is equal to dx. So now all of this is what I'm going to use to substitute in. So instead of dx, we're going to write 1/2 du. If I know what's going on, I can go ahead and move that 1/2 to the front without having to do anything extra. So I can make this my step together. And we give the square root of u du. We don't really know the integral of square root of u. We wouldn't even take the derivative of the square root of u. We would take the derivative of the square root of 1/2. Or not the square root, u to the 1/2 power. So we're going to take the integral of u to the 1/2 power du. We are now just using power rule. So power rule, we add 1 to our exponent and then divide by that number we added. So I have 1/2 up front. I have u to the power of 1/2. We're going to add 1 to it, so we're going to do 3/2. And we're going to divide it by 3/2. Okay, so now all we're going to do is kind of make this a little bit easier. I'm going to wait to put stuff in for you because it's just going to add more stuff in. So we're going to simplify these numbers first. So I have 1/2. I have u to the 3/2 divided by 3/2. When I divide by a fraction, I'm going to multiply by the reciprocal. So I'm going to multiply instead, and the reciprocal of 3/2 is 2/3. U to the 3/2. So now I'm going to go ahead and put these together. We are multiplying by 1/2. 1/2 by 2/3. If I multiply straight across, I get 2/6. That reduces to 1/3. Those 2's cancel out because they make a 1. So I get 1/3 u to the 3/2 plus c. I'm going to go ahead and now plug the 1/3 or the u back in. So I have 1/3 times the quantity 2x minus 1 to the 3/2 power plus c. We don't know what c is, so we're just going to have a lot of c's. So overall, this is just we're missing a factor of 1/2, being able to change some stuff around, and then we can do this. Not too bad. The only difference between this one and the last one is going to be this x that we have here. So if I got rid of this, it would be the exact same problem. So in this one, we are going to legitimately make u the exact same thing. It's still an inside function. So I'm going to make u 2x minus 1. This means if I take the derivative, du is equal to 2 dx. And just like before, we want to get dx by itself. So we're going to divide both sides by 2. And we get 1/2 du is equal to dx. So if we look here, we have this piece here, which is going to take care of u. We have this piece here, which is going to take care of the dx. But we don't have a thing to take care of our x. We don't have anything to take care of this. So we're going to write out what we have so far. So we have the integral of whatever x is. We have the square root of u. Instead of dx, we're going to do 1/2 du. Well, the really nice thing is I have x right here. And I need it to be in terms of u. So we are going to take this equation, u is equal to 2x minus 1. And we are going to move it around so that way x is by itself. So I'm going to add 1 to both sides. And then we're going to divide it by 2. So u plus 1 over 2. That is what we're going to be plugging into our function. I can go one step further if I want to and separate this into 2 fractions. So u over 2 plus 1/2. It just depends on what you're feeling like. to decide how we want to simplify this. Doing the latter of those two is going to help a little bit. So we have u over 2 plus 1/2. So we have, this is our change for x, which is all of this right here. We have our change for u, which we've filled in, and our change for dx. So we don't have anything in terms of x, we're all in terms of u now, and we can kind of start simplifying. So we're going to move the 1/2 out front. It's a constant. We're going to change what the square root of u looks like. It's u to the 1/2. And I'm going to move it conveniently in front of our parentheses. It's multiplication, so it doesn't matter what order we do stuff in. So I have u over 2 plus 1/2 du. There's one more thing that I can do if I want to. This over here, we have u over 2, u to the 1/2, so I could pull a 1/2 out of everything and make this u plus 1. We're going to do that so that way we can get a factor of 1/2 out. So I have this 1/2 out front. I have u to the 1/2 times 1/2 u plus 1. 1/2 is also a constant, so we're going to just pull that out. It's being multiplied by everything, so that's fine. 1/2 times 1/2 gives me 1/4. So I have 1/4 the integral of u to the 1/2 times u plus 1. Okay, so we still can't quite integrate this yet. We need to make it a little bit more simplified, and we're going to do that by distributing this u to the 1/2 to u and to 1. So I have 1/4 the integral u to the 1/2 plus u to the 1/2 times u plus u to the 1/2 times 1. Well, that's u to the 1/2 times du. U to the 1/2 times u to the first power. When I multiply things of the same base, I can add their exponents. So I have the power of 1/2 plus the power of 1. So I have the power of 3/2. Now I can use product rule. So I have 1/4 times. So we have u to the 3/2. We're going to add 1 to it. So now we're going to have 5/2. And then we're going to divide by 5/2 plus u to the 3/2 divided by 3/2 du. If we see a pattern, we can start pulling and making things faster. So I have 1/4. So if I see that dividing by a fraction is the same thing as multiplying by the reciprocal, I might start writing, oh, well, we're u to the 5/2 times 2/5 instead of saying divided by 5/2. But that just takes practice, finding patterns. Instead of dividing by 3/2, we're going to multiply by 2/3. And we are going to add our c. So I'm going to multiply these together. So we have 1/4 times 2/5. That's 2 over 20 or 1 over 10. 1/4 times 2/3. That's 2 over 12, so 1 over 6. And so now that we've simplified this all together, we're going to go ahead and plug u back into this problem. So we have 1/10 times u is 2x minus 1, so 2x minus 1 to the 5/2 power plus 1/6, 2x minus 1 to the 3/2 power plus c.